We began this short course by pointing out that the Mathlets can provide a powerful enhancement of the traditional lecture. The Mathlets offer an even more powerful learning tool if the students operate them themselves. We've talked about one context in which that can happen, in group work, either in a lecture setting or in smaller groups. Mathlets can be integrated into homework assignments for individual students as well. Of course, for this to work, the student must have access to the Mathlets. Currently, the applets are mostly implemented in Java, which students can access anywhere on their own computer. And we're in the process of translating Mathlets into JavaScript, which will enable you and your students to access them on tablets and even smartphones. My objective in this module is simple: to describe the use of Mathlets in homework. But before we see the examples, I have two general pieces of advice to give you about basing homework problems around Mathlets. First, generally speaking, you have to be very precise in your instructions about the use of Mathlets in homework, much more precise than in projects descriptions designed for group work. And second, your students will be much happier using a Mathlet if you have already demonstrated it in class. The two segments of this module represent various types of homework assignments based on the Mathlets. After each one, I will discuss the decisions I made in framing the homework problem as I did. And at the end of the module, there are some exercises for you. Now, please see the course website for a text of some examples in using Mathlets in homework. Welcome back. Needless to say, in assigning homework using the Mathlets, you have to be sure that your students have access to the Mathlets. Equally obviously, any use of this technology has to fit into your own syllabus. A good strategy is to look through the list of Mathlets and pick ones that fit your needs. In any case, I think these homework examples illustrate several other virtues of the Mathlets. For one thing, students learn best when they can work with the Mathlets themselves. Part of this is the power of kinesthetic learning. The process of physically manipulating something and observing the effect is a powerful educational strategy. It helps the students create a mental map, situating a range of observations in relation to each other. Sometimes I call the Mathlets manipulatives, referring to the learning tools employed by Montessori schools. Students also find satisfaction in the manipulation of the Mathlets. They find it rewarding to match observations with the results of computation. This feedback is valuable. A distinction has been made between two different types of feedback on student performance. Intrinsic feedback refers directly to the correctness of the student performance. In contrast, extrinsic feedback refers to secondary qualities such as being a good student. Teachers very often resort to extrinsic feedback. Students like to be complimented, but to be most useful as a teaching strategy, the reinforcement has to be tied directly to the desired performance. Computer-based educational material is particularly effective at giving feedback directly related to specific student performance. And finally, the frequency response Mathlet illustrates how the Mathlets support transfer. By linking the abstraction of the mathematics to the concreteness of a model, the Mathlets help students connect skills learned in a mathematics class with applications outside of the class. Please see the course website for exercises in using the Mathlets in homework.